Dear students, we are going to start electronics syllabus. In electronics subject, there are two papers. First paper is applied electronics and second is digital electronics. In first paper, applied electronics, there are 6 chapters. So first chapter is instrumentation. Today we are going to study first chapter, instruments. It has 15 marks. In this chapter, we are going to study 3 major devices. Those are CRO, cathode ray oscilloscope, function generator, and digital multimeter. In CRO, cathode ray oscilloscope, the main component is CRT, cathode ray tube. This is the figure of cathode ray tube. The figure consists of 4 main components. First is electron gun assembly. Second is a deflection plate assembly. Third is fluorescence screen and aqueduct coating. So in electron gun assembly, there are different components. Those are filament, cathode, control grid, pre-accelerating anode, focusing anode, and accelerating anode. The purpose behind electron gun assembly is to generate narrow and sharp electron beam. But this beam has to be deflected onto the screen vertically as well as horizontally. So it requires deflection plate assembly. Deflection plate assembly consists of vertical deflection plates and horizontal deflection plates. There are 2 pairs for both applications. Vertical deflection plate is arranged horizontally. Horizontal deflection plate is arranged vertically. Next is fluorescence screen. This is thick glass tube which is internally coated by phosphor. So it has tendency to emit light when high velocity electrons bombard onto it. This property is fluorescent property. That's why the screen is known as fluorescent screen. Last is aqueduct coating. Aqueduct coating is graphite coating which is internally coated to the CRT. This is useful to retransmit low velocity secondary emission electrons towards the screen. That's why screen becomes brighter. Now, how electron gun assembly plays the role? When filament become hot, cathode is mounted onto filament. Cathode has given very high negative voltage. Since light charges repel from each other, so electrons emit from cathode and they spread towards front. But these electrons should be converged at the center. It requires control grid. Control grid is mounted near to cathode, which is cylindrical disc and having small aperture at the center. We can vary voltages given to control grid by intensity control. Now, control grid converts these electrons at the center and passes through its aperture towards the screen. Now, pre-accelerating anode, focusing anode, and accelerating anode has given very high positive voltages. Comparatively, focusing anode has given less voltage than pre-accelerating and accelerating anodes. That's why concave lens effect is occur, so that a converged beam is produced. When electron passes through these 3 anodes, Then very sharp narrow beam is formed onto the screen and it makes a spotlight onto the screen. But this spot or this electron beam has to be deflected vertically as well as horizontally by using deflection plate assembly. There are two pairs of vertical and horizontal deflection plates. One pair is for vertical deflection and other pair is for horizontal deflection. Vertical deflection plates are positioned horizontally, which divert electron vertically. According to input voltages given to vertical plates, electron may divert to the up either down of the screen. Similarly, horizontal deflection plates are arranged and it has given sawtooth voltages. These plates are arranged vertically, which diverts electron beam horizontally towards left either right. So it is the combined effect of both deflection plates. That's why we can observe a trace or waveform onto the screen. Now, fluorescent screen. It is thick glass tube which is internally coated by phosphor. This phosphor is alloy material which is made up of metal, non-metal, or some minute mixture of radioactive material. It has tendency to show light when high velocity electrons bombard onto it. Now last is aqueduct coating. Aqueduct coating is graphite coating. When secondary emission electrons has to be retransmitted towards the screen, then graphite retransmit these electrons towards the screen so that screen is more brighter. In this way, we have studied all components of CRT, and so CRT is useful in CRO for electrostatic deflection. So how this electrostatic focusing is done in CRO? Let us look at this figure. In this figure, we have just magnified how electron is diverted and focused onto the screen. Now here at the center filament, it is covered by cathode. Again, it is covered by control grid. These are cylindrical discs and this has given a different voltages. These voltages can be controlled by using external controls like intensity, focusing. Now there are three anodes: pre-accelerating anode, focusing anode, and accelerating anode. By using variable potentiometer, we can vary the focus control. Here, equipotential surfaces are formed due to the voltage differences. It shows like concave lens effect. And because of that, when these electrons spread within this cavity, then these electrons converge and which makes a narrow and sharp beam which bombard onto the screen. Now, on the screen, a spotlight is formed and that may be diverted using deflection plate assembly. In this way, electrostatic focusing is used in CRO. Next is How deflection plate assemblies are useful in CRO. In CRO, deflection system is electrostatic deflection system. Let us look after this figure how electron beam is diverted, either deflected onto the screen. These are the deflection plates. This plate has given input voltages. When electron passes through this cavity, already this portion has produced electromagnetic field. If there is more positive voltage, so more positive charge is produced here. Electrons may attracted towards this positive charge and electron beam deflected towards up. Similarly, if positive charge is produced at the down, then electron beam may deflected towards down. In this way, the deflection of electron beam is the combined effect of vertical as well as horizontal deflection plates effect. Now, how we can determine the sensitivity of electrostatic focusing system? By using this formula, F equals to D upon ED, where D is distance of the deflection and ED means deflection voltage given to the deflection plates. So the unit of this electrostatic deflection is meter per volt, but practically meter is not possible, so it may be measured in mm per volt. In this way, we can determine the sensitivity of electrostatic deflection system. Okay, so today we have studied CRT, cathode ray tube, electrostatic focusing system, and deflection systems in CRO. So take care. Bye.